A person takes a tennis ball and throws it upward with a velocity of 15 meters per second and catches it when it comes back down. How long was the ball in the air? We have our picture drawn. Here's the person. They throw the ball upward. It's going to come back down, and they're going to catch it. We have to pull our numbers out of the problem. We do know that we're throwing it with an initial velocity of 15 meters per second. So that's our V naught. Anything that's going up and coming back down has an acceleration of negative 9.8 meters per second squared. And now a common mistake is there is a zero here, and a lot of people want to put zero at final velocity. Don't do that. The final velocity of an object that you throw up in the air is only zero at the highest possible point. But we're not worried about the highest possible point. The question is not asking how long does it take to get to the highest point. It's asking how long does it take to go up and come back down. And this is where displacement, being different than distance, is important. Displacement is how far away the ball is from some starting point. Well, if the starting point was in my hands and the ending point is in my hands, then I'm nowhere. I haven't gone anywhere from the starting point. So my displacement is zero. And the question was asking, how long does this take to go up and come back down? So I'm going to pick the equation without VF in it. That's D equals V naught T plus 1/2 AT squared. To solve for time in this equation, to rearrange this with all the letters in here, does get a little bit tricky because this is a quadratic. We have T, we have T squared, and as a result, I'd have to use that quadratic formula, that negative B plus or minus square root of B squared minus 4AC all over 2A thing. But we actually don't have to do that when D or V naught or A, if any of those are zero, then I can plug the zero in, and this is going to simplify much, much easier for you. So I'm going to plug the zero in for D, and what I get then is 0 equals V naught T plus 1/2 AT squared. Now I can divide everything by D, because 0 divided by T, divide everything by T, because if I divide everything by T, there's not going to be an extra T in the denominator over here to mess me up. So if I divide everything by time, that's going to go away, that's going to go away, and that's going to remain 0, giving me 0 equals V naught plus 1/2 AT squared, which is a whole lot easier to do than having to do the quadratic formula. Oh, and we got rid of the squared when we divided by T. Should have wrote that, force a habit. So, okay, 0 equals V naught plus 1/2 AT, because the T got rid of the squared, the T divided out the T and the V naught, and 0 divided by anything is still just 0. So now we can solve this thing for time. I'm going to move V naught over by subtracting. So minus V naught on both sides, and then negative V naught equals 1/2 AT. I'm going to get rid of the half by multiplying by 2. So I can get rid of that by multiplying 2 over to the other side. So now I have minus 2 V naught equals AT, and I can divide by A to make the A go away. So negative 2 V naught divided by A gives me time. I can plug in my numbers. Negative 2 times V naught was 15 meters per second. Acceleration is always negative 9.8 meters per second squared, and that's going to give me the time. Plug that all into your calculator, and you should get 3.06 seconds for how long it takes the ball to go up and come back down.